Welcome to the Creation Show. I'm your host, Sonino John Paul Scardelletti. Thanks so much for tuning in. Folks, a while back in September, I was at the Akron Fossils and Science Center in Copley, Ohio, just outside of Akron. I watched a fantastic lecture on astronomy by astronomer and chemist Ken Keir of Keir Technology. We had him on the program. He's back for round two. Ken Keir, thanks for coming down from Akron, Ohio.
Thank you.
I was riding around last night, and I looked up at that familiar thing, the moon, Ken. And I remember we talked about it last time.
Right.
Now, about 250,000 miles away. I found it interesting that the Soviets put an unmanned spacecraft on the moon in 1959, but never put a guy on the moon like we did in 1969. In fact, to date, folks, no one's put a man on the moon except America. But the question I want to ask you is, Ken, the last show we talked about the sun, how it looks like this massive orange ball in space coming, shining at us. But you said it's white, which it is in outer space. It looks orange or yellow because of the rays going through the atmosphere.
Correct.
Now, the moon looks white. I'm thinking, well, it's the sun's rays on the moon reflecting. Why doesn't the moon look orange or yellow when we see that?
That's a good question. And we find it, since you have a white sun shining on the surface of a planet that basically is kind of a neutral grayish color, there's areas of it that are brighter and some areas are darker. So most of the light coming off doesn't have like a blue hue or a green hue, like if you were looking at the Earth, you'd see green from the land, blue from the water. From there you see just basically almost a gray or white color. And we see it white because there's no atmosphere for the light from the sun to get to the moon. So the white light is falling directly on the moon, and then it's coming directly at us. So when the moon is up in the sky, like you saw it overhead last night, it's coming through just a small amount of atmosphere, and you really don't have much light scattering there. So it does still look pretty much white. You also have the large contrast factor. Your eyes are used to the darkness that's out there, and a bright light, just being bright, will actually have like an overwhelming effect on your retina, and that will make it look even whiter than it might if you didn't have that. We still must get light scattering, though, from the moonlight coming through.
Yeah.
If you've ever been out there on a dark night with like a full moon, you look around and the sky is like a deep indigo blue. It really does have a blue hue even from that.
The moon, another question. On the last show I asked you about this. I said, Ken, if God reached out and grabbed Jupiter, this massive planet, and took it away in 1 second, what would happen to the rest of the planets in the solar system? You said basically, well, they're so far apart that maybe nothing might happen. Now, the moon's close, 250,000 miles away. If God snatched the moon right now, what's going to happen down here on Earth if it's gone completely?
Well, if we just did that, and God would have to do some very miraculous things for that to happen, because there are some laws of nature that he's put in place that we know that always work. You always have the conservation of momentum, you have the conservation of energy or mass. The two we found are basically equivalent, so we can make atomic bombs.
Yeah.
So you're either one or the other, or a combination of the two. So when the moon disappears, we're taking away some of this momentum of it going around. It's actually in a circle as it revolves around the Earth. So it's an angular momentum, and that's a more of a physics term. That angular momentum still has to be there in the system. There's an energy associated with it. So as the moon was pulled away, you'd find things happening just because he pulled it away. If he decided to just make it disappear, and all of a sudden it's no longer there in space, the system would have to have something kind of probably respond to it. You'd have to see what God would decide to do. So some of that would be definitely supernatural occurrence, but we'd lose the tides. We wouldn't have tidal effects going on any longer. Some of that shows up in things like the Earth rotation is slowing. We find that the tides are kind of dragging on the angular momentum of the moon going around the Earth. So the moon is actually traveling a little bit slower, which means each year it gets about a half an inch further away from us.
Yeah,
so
I heard that. Yeah.
It's moving outward, and part of that's all because of this combined drag effect that we have between the two.
And we only see one face of the moon all the time because the moon is turning, we're turning. Now, if the Earth stopped turning, which might kill us, I don't know, then we would see the other side. A lot of folks think we're seeing both sides of the moon at the time, but we only see one side constantly?
Well, that's not true. If the Earth just stopped
Yeah.
and the moon just kept still going around us, it is rotating at the same period it takes for it to go around. So for it to turn halfway around on a rotation, it's also at the same time revolved halfway around its orbit. So now that same side is still pointing at the Earth. So even if the Earth were stationary right there, we would still see just that one side of the moon.
Wow, we can never see the other side of the moon. How tragic. On the way in, on the radio, Dennis Prager show, conservative talk show host, had a scientist on. They were talking about the Big Bang. And the guy said, well, now the Big Bang might be obsolete because they think there was many, many Big Bangs. Well, the theory started back in the 1920s. A Belgian Roman Catholic priest and a professor of physics and an astronomer, I hope I say his name right, Georges Lemaitre, come up with this idea that there was nothing. All of a sudden, this atom appears with all this energy, blows up, and for trillions of miles, and, well, untold trillions of miles, in all directions, we get a universe. That's what the Museum of Natural History teaches, that everything came out of nothing. What is your take as an astronomer on this Big Bang belief?
Well, as a Christian astronomer, which is the approach I'll take from it, where you still apply scientific principles, but you try to do it in terms of what the Bible is telling us about how things work. And I like in Psalms where it tells us, I'll read this Bible verse, that the heavens declare the glory of God, the skies proclaim the works of his hands. Day after day they pour forth speech, and night after night they display knowledge. There is no speech or language where their voice is not heard. Their voice goes out unto all the earth, their words to the ends of the world, and in the heavens he has pitched a tent for the sun. We see now that God has put this here for our benefit, but also to display his glory. And you cannot help but look at that universe and say, there's something way beyond normal mankind, just forces of nature kind of things happening here that allow us to ponder our existence, the existence of where we are. So the Big Bang has come out of those kind of thoughts. And it's trying to explain some things that we're seeing in terms of the redshift of things moving away from us. The farther away things are, the more the redshift, so they seem to be moving faster. So you combine that all together and they've come up with the Big Bang. When they've done that, though, there are still problems that the Big Bang doesn't fully explain. I don't know that I understand all of that and don't recall at the moment to get into it. But it turns out that basically anything that can be proposed often has flaws with the theory. And so the Big Bang, the way it's been proposed, probably doesn't explain it. And the Bible explaining that God created it, it's his creation. He could start out with it in an instant and then basically unveil it at his speed,
whim,
whatever he'd
yeah.
like to, instantly, take a few years, take a couple of days. Why couldn't he take a million years? Why couldn't he take a microsecond?
Oh, yeah.
And so it could be anything in between. And so for us to look at it and say, God tells us in the Bible he stretched out the universe. And when we look at the universe, we see it's stretching it. I mean, we see things moving further away from us, and the further away it is, the faster it's moving. And I know that the Big Bang guys now, with their different dimensions, with their string theory, that there's a lot of different dimensions, they think, that describe us, that things could be existing in another dimension. So they've come up with this idea now, and I've read some articles on it, I don't remember all the details, kind of into keeping up with this stuff. So they propose there's multiverses, that you have Big Bangs at different dimensions, different times, and yes, there is a thought pattern that if there was a Big Bang once here, and there are other dimensions, why couldn't there also be more of them?
Sounds like these guys are looking for anything except God making the universe. That's how I take it. Ray Comfort, and a creationist, he's got a book that I have at home called Nothing Created Everything. Our Museum of Natural History in Cleveland believes that. If you go in there and see their exhibit on the Big Bang, it says everything came out of this Big Bang from nothing, time, space, matter, energy. I've tried to picture, Ken, what nothing is. And I can't picture what nothing is. Getting back to the universe expanding, expanding into what? So what do you think nothing is? I don't know what it is.
Yeah, it's not something we can physically relate to. And it's not like we've just gone into outer space and we're sitting up there, because outer space still has dimensions. It has length, depth, width. And so we still have those dimensions. We still also have the dimensions of time. The time is moving ahead, and we just don't have the ability to go back in time. But it's also in other dimensions. So the physicists talk about space-time, and that's one area we deal with all the dimensions. What does it look like if none of those exist? And it gets even more complicated, because if they propose that we have a Big Bang and from nothing came the universe, and now they're proposing the string theory idea with multi-dimensions, well, where did all the multiple dimensions come from as well? They would have had to have come about at the same time. And the theory does get a little complicated, I think, and that has some big holes in how you really defend it and explain it. And a lot of that just from a philosophical basis, but there are probably some good scientific and mathematical arguments as well. But just think about it. We're in a place where there's no light, there's no gravity, there's no warmth, there's no sound, there's no touch, no water, no food, no air, no oxygen. I mean, it's beyond a complete vacuum. There's absolutely nothing there. If we're out in outer space and it's like that, say we were somehow dropped off accidentally on a spaceship in deep space, we would have basically that same kind of event happen to us. We'd have none of those comfortable things around us that we need to survive, but that still wouldn't be nothing. Nothing would mean that there isn't even the ability for my body to exist in a space or a dimension, and there wouldn't even be ability for subatomic particles, the protons, neutrons, the quarks and things of that sort that we have that make up the protons and neutrons, that none of that would exist, that there just isn't any dimension or space for it. So we can't relate to it physically.
Yeah, but they still believe that, again, that, like Comfort said, nothing created everything, which is definitely against physics. I mean, right now, as it stands, is that against physics? I mean, I think we agree on that.
Yeah, it is. I mean, for things to exist, there has to have been some source of the energy and matter that is there.
Yeah.
We know that that's a conservation of the universe. And therefore, for the universe to exist, even to come from like an instantaneous point and expand, which maybe it did, maybe that's how God did it, it takes an external force. It takes a force that's outside of the universe. It takes a force that's an energy source that's greater than the universe to bring something like that even into existence. And ability is way beyond ours to understand of how you even decide to make dimensions come into existence and time come into existence, how to make the idea of light coming into existence. That talks about some sort of a being that's way beyond, and that's what basically being here in a creation just absolutely mandates, that there has to be something beyond the universe for it to even exist. And that's why I think the heavens do declare the glory of God, because as you start digging into it, you realize it just couldn't have been here by chance.
Yeah, I agree. From what I've picked up on the computer, we can see about 4% of the matter and energy in the universe with these telescopes. Mm-hmm. Galileo Galilei, about 400 years ago, started showing people how to use a telescope to look at the universe. Here's a great quote from astronomer Dr. Nick Lam. "It's still extremely embarrassing to astronomy that we can only see about 4% of the matter and energy in the universe." Now, some of the most powerful telescopes, well, there's one in Sydney, Australia, in their observatory. Mm-hmm. But with these scopes, the best we have in the world, how far out in miles, or in light years, I should say, can we see? How far can we go?
Well, the limits that they know of right now are calculated based on Hubble's idea of the redshift factor and the distance away from us. And so the things with the largest redshift are quasars. That stands for basically quasi-stellar objects, stellar meaning star. And so they're out there, they know they're extremely intensely bright, and they have such huge redshifts, they basically have to calculate or assume that they're at extremely great distances. And the distances they think they're at are of the order of 13.5 billion light years to 14 billion light years. So they, based on that, we have light coming back to us from objects that we think has taken that long to get to us. Now, out in that region of space where we can see something extremely bright, are there other just normal stars and galaxies and things of that sort? And the answer probably is yes. If there's an extremely bright object out there, there's probably other normal objects, and we can't see those. They're too far away. They don't have enough light being thrown at us. And what's beyond the quasi-stellar objects? If they were right, for instance, that the universe is 13.5 billion years old, well, what says that there couldn't also be quasi-stellar objects that are 26 billion light years away from us, and the light just hasn't had a chance to catch up with us yet? So the question here is one you really don't know that you ever are going to have an absolute answer to. And if somebody proposes answers, you have to compare it to theories, compare it to ideas, what you do know, and make some judgments. And as I said, I think almost all of them have some point of failure in trying to explain it.
Just so the audience knows, a light year is about 6 trillion miles in length. So you're talking 6 trillion miles times 13 or 14 billion. Mm-hmm. That's how deep we could basically see.
Yeah.
I can't even imagine that kind of a distance, but it's out there.
I was thinking I might have even calculated that and have that in my notes, but yeah, I don't see it right here. But
okay. The redshift, you mentioned that. Mm-hmm. For the audience, take it from the top. What is this redshift all about? The phrase has been all around. What is it?
Well, redshift has to do with an object in motion will be emitting something. So let's take something familiar like a boat moving through water. And so that object is moving through a medium, the water, and it's making waves. And what happens is it makes waves. We'll notice that in front of the boat, if the boat's not traveling too fast, the waves can still move ahead of it. But we see that the waves are very much compressed together, because as soon as the wave moves out, there's another one being made by the boat. And as you look behind the boat, they're now waves, but they're kind of stretched out because the boat is pulling away from it, so there's a larger distance between those waves. We experience this all the time, and know it happens in sound. And you know it when you listen to a car drive by you is one of the places you pick it up. If you ever listen to the microphones at a racetrack at the Indy 500 or something, you always hear this high-pitched scream it goes roar down to a lower roar as a car goes by. That is a shift factor, and it's basically a similar redshift, but it's with acoustics. So when we see light coming at us from a star, if the star is moving towards us, now the star is making so the light waves will be more compressed, like we saw with the waves in a boat, and that's considered a blue shift, because in the spectrum, the stuff that's closer together has a higher frequency to it, and it looks blue. If it's longer wavelengths are down on the red end, so we see those for objects that are now moving away from us. And when we look at things that are happening on that object, and we can look at things like the hydrogen lines, the helium lines, the presence of carbon and things of that sort, they're very specific spectroscopic lines. And what we see is that those are shifted in the spectrum. They're like showing up at places that they don't normally fall. And this was their great discovery, that they're actually the same thing, but they're moved. One's moved in the red direction, or they're moved in the blue direction. Almost everything we see is moved in the blue direction or red direction. Only a few things are in the blue direction, which means basically everything's moving away from us. And the faster it moves, the more the shift towards the red. So that is how they tell how fast an object's moving away from us. And the theory that Hubble came up with is that means if it's farther away from us, what he has concluded, and they tend to be fainter, as he's concluded, are also farther away. And so he's developed a little scale that you can use the redshift factor to try to calculate how far away an object is.
And what do they point at these stars to get this redshift? What instruments are we using for this?
Well, it's a spectrograph. Basically, it's like when you go outside with your little prism when you were a kid. I did this a lot.
I remember prisms. Yeah.
And especially in the house, they were a lot of fun when you catch a sunbeam coming through it, and up on the wall you'd see a rainbow. That is what we're doing. And a device that does that sometimes just has a bunch of lines etched on it. That'd be a diffraction grating. It'll also reflect that in the same way, making a spectrum. And when we put it on a telescope or on other devices, we call it a spectrograph, because now we can make charts and graphs of it. And basically the scientists are now measuring that. What's the intensity at the different colors, or that actually translates into wavelengths or frequencies. And so from that, they find that certain elements always have a line or a band that shows up at a certain frequency. And it's how chemists a lot of times will characterize what's the elemental makeup of something. There's a lot of the inorganic analysis that goes on these days. There's copper there, there's manganese there, et cetera. They're looking for those lines in a spectrum to see if they're there. And we find them in the stars, but the catch is in the stars, they're shifted.
So we can tell it's moving away. We can tell basically how far it is and the makeup of that star with these instruments we have. Black holes. They've been in movies throughout the years.
Yeah.
People falling in them or something like that. I've heard scientists say, well, you know, their theories or whatever. What is a black hole? Do they really exist, or is it we don't know if they exist?
No. I had read a while back that it was something was proposed back in the 1700s that perhaps there was a gravitational field of an object that was so big and had such a high field that light wouldn't be able to escape from it. Well, that was just an idea back then. Scientists proposed a lot of crazy things back then. And some of the ideas over the years have proved out, and that's why we do scientific testing to develop a theory, develop tests we think will evaluate that theory and see what the results look like, and from there conclude whether or not that theory seems to be valid or not. And the black hole idea came out of, especially crystallized from Einstein's theory of general relativity, which found out that light is affected by a gravitational field. And as you see light go by an object, and particularly, let's take the sun out here in front of us, and there's a star behind the sun. As the light from that star gets close to the sun, it's going to have to travel to us to be able to see it just right near the edge of the sun. Now, this is hard to do in the daytime, so it works better in eclipses and things of that sort. And the scientists can measure very precisely exactly where that star is. And if as it gets close to the sun, it no longer is precisely where it used to be, but it's deflected, then they know that the light coming to us from that star has actually been bent by the gravitational field. And that's how they proved, one of the main proofs that there is that the general theory of relativity is right. And from this, we've seen other factors like gravitational lensing that have shown us that there must be a black hole in outer space, because we can see a galaxy, but kind of the light from it comes on both sides of this and it's curving around us, so we're seeing lensing effects. And the black hole is something that now is so dense, the gravity is affecting the light, that as stuff gets in closer and closer to this black object, it reaches a point, a limit, at which once it gets beyond that point, the gravitational field is so intense that the light can't even escape back out. It's forever captured into basically just circulating around this star. And exactly what looks like is something that really can be proposed, but there's no way to really even test it. Black holes are kind of interesting objects.
Now, are they as big as a? I mean, are they big as a planet? What are they? I mean, the hole. How big is the actual hole they're talking about, if it exists?
Well, basically, it'll be probably pretty small. And there are stars that are 1.5 times, say, and more. I think they believe there's black holes that are as large as 10,000 times the sun's mass. That in the center of most galaxies, they think there is a black hole there that has a very high gravitational field, and that's why everything is spinning. That as the things fall in towards it, the angular momentum has to be maintained, so they start to go around in a circle, and they make these whirlpool patterns and things that we see for these galaxies. And it's all because that there's this black hole. Also, because the black hole and things are orbiting it, it basically develops kind of a sling effect that you would have as it rotates. It's always going to keep it away from it. So a lot of things are never going to fall into the black hole, just because the black hole is kind of holding things there, if you will, because of that. So I think that if you get, I think the number is about 1.4, if I remember reading it right, times the solar mass. As these things start to collapse when the star is dying, they won't collapse to a black hole, but they will collapse down to a white dwarf, which is extremely dense. So all the space that used to be in the star is now down into something that's probably the size of Jupiter or so.
Yeah.
And then it's possible for things then, if they're slightly larger than that, to also collapse even further, where basically everything falls into, all the atoms collapse in on themselves and they become nothing but just neutrons. And they call that a neutron star. It's basically pure neutrons, just one packed next to together, all the gravitational field of all those neutrons holding each other together. And I don't know what they've calculated as the size of that might be for a star that's maybe about 1.5 or 2 times the size of the sun, but it'll go there. Stars that are larger than that, once they start collapsing, it'll just zoom on past the neutrons collapsing and also collapse on down even further. They'll make the neutrons crash into each other and go even smaller, and that's when you get the black hole.
Yeah.
And the catch is the black hole now has this, what they call the event horizon around it, where the gravitational field is so large now light can't get away from it. So theoretically, black holes can be fairly small, 3 times the size of the sun or so in terms of actual mass, up to tens of thousands or maybe more than the sun.
It's just hard to imagine that light could not escape from something, because we can't grab light. But I guess what you're saying is gravity can grab light. And so light perhaps has maybe a solid principle to it that, you know, something to grab onto.
Yeah.
It's really amazing.
Yeah, it really does. And you can associate that. That's one of the things that Einstein also discovered about light and its wave nature, and also basically its particle nature. And we think of light as a wave, and most of us have learned that in school, and we associate it with that way, but we forget that it also has a particle nature to it as well. So we talk about photons, and photons are the description of what the light wave looks like when it's acting like just a single particle that also has a wave behavior to it. And it is going to be affected by gravity just in the same sense as apparently other particles are. And we're not talking ordinary gravitational fields here. We're talking fields that go way beyond anything of our ability to understand, that you just can't imagine something that would just immediately suck you in over the speed of sound just instantly when it's still thousands of miles away from us, for instance. And that is what we're talking about with a black hole, and why light is so dramatically affected by it.
I mentioned before we landed on the moon in 1969. Or did we? Now, I'm just going to throw some at you here. You know, these guys out there talking about we really didn't go to the moon.
It's conspiracy theories, if I can.
I believe we went to the moon. But they got some videos out there that I've seen. Almost called "A Funny Thing Happened on the Way to the Moon," and it was only a paper moon. In other words, these guys are saying they did it on a set, on a studio set. They point out some interesting things that look kind of silly if we really did go to the moon, from the photography, from the ship and this stuff out in space. It doesn't. They're saying, well, there shouldn't be shadows here, et cetera, et cetera. But the one guy talks about that we didn't go because no astronaut could get to the moon. He'd have to go through the Van Allen belt. The Van Allen belt. He said he would die. Well, what is this Van Allen belt that he's talking about?
Well, it's actually a good point that they're bringing up, that in outer space we have this radiation that you get exposed to, and subatomic, subnuclear particles that are being accelerated and passing through space with extremely high energies. The Van Allen belt is an area that's just above the surface of the Earth. I think it's up about 60 miles to a couple hundred miles, maybe further out than that. I read some information here on it that even said there's 2 layers to it. One's more of a positive charge, one is more of a negative charge, but it's basically radiation you're going through. And there are times when there's large solar flares that Van Allen belt has an awful lot of radiation associated with it. And it would be true if you're out in outer space at that time, when those nasty solar flares hit. And some of these solar flares back in the 1800s, there was one set of them that were so bad, they knocked out telegraph systems. And they're saying that the sun periodically does this, where there's a large flare with a lot of these particles being bombarded out into space. The Earth's going to get hit by them. And they're saying it would probably nearly wipe out our civilization, because if it'll wipe out a telegraph, which is just wires and a magnet that go clickety-click, imagine what they'll do with all these fancy electronics we have. And we hear people talking about the electromagnetic pulse bombs that they can make now, that people are saying that they can make a nuclear weapon that basically shoots out such a large magnetic pulse that really never destroys anything much from the explosion, but the magnetic field just absolutely decimates everything else that's electronic in a way. And we're kind of looking at something of that caliber that is out there in space, that periodically hits the Earth. Normal intensities are enough that it would begin to affect a man in space for a while. Some people have even proposed that if you're out there for a couple of years, you might see some serious deterioration. Other times when you see these large solar flares, if you're exposed to it just for a minute or so, you're probably dead. It'd be worse than stepping inside of a microwave and punching it on, basically, is what we're talking about here. And there was one of the Apollo missions, they said, when the astronauts were coming back shortly thereafter, there was a huge flare like that came up. So there was just a bombardment of radiation. If those guys had been traveling back at that time, we'd have got a capsule back with dead bodies in it.
So they did go through this belt, but apparently the radiation didn't affect it.
And if it's mostly just protons and electrons, positive and negative charges, those are going to be kept more neutralized by metal. That metal is pretty good at being a conductor, so it acts basically like a shield pretty nicely to that. But it's these cosmic rays now that have much higher energies and are able to penetrate right through. I mean, they can pass right straight through the Earth and not even hardly slow down. And they have massive amounts of energy. When they do hit something, then they can release massive amounts of energy and do a lot of damage when there's a lot of them.
Okay. Throw some names at you. Halley's, Shoemaker Levy 9, Hale-Bopp, Swift-Tuttle. These are comets. Of course, Halley's, first spotted in 1531, then again in 1607, every 76 years. Now I got to tell you this, Ken. You and I are not going to be around for the next one.
Nope.
2061 looks like, so I don't think we're going to make it. But what are comets? Where did they come from?
Well, comets are an interesting thing. They are objects that appear to be a lot of ice in them, or maybe they could actually be a frozen ice of ammonia and methane and hydrogen itself frozen into ice form. They're from basically the outer parts of the solar system, and because they're being affected by the sun's gravity, we find that they fall in towards the sun, but they're moving so fast that they accelerate around the sun and then slingshot on their back out, and then come back in again because of a very long elliptical orbit. These things are being proposed by scientists as coming to us from a belt way outside the solar system, and they're occasionally being bumped together, or another object comes along, disturbs it just enough so it starts to fall in towards the sun, and now we have another comet. That is probably a good picture of what could possibly happen. I think that some of these things may have been around from things like large meteors crashing into a planet like Neptune or Jupiter, that are these large gas giant planets and the ice planets, and some of that material being ejected into space and then being able to fall back around the sun. Now, since it's an object that has a lot of either low temperature liquid or ices around it, could be just water, could be ammonia, other small molecules like that. As they get close to the sun, now they will begin to evaporate or volatilize, as we would say. And what it means is, just like you look at water steaming off the top of a boiling kettle, these things are now doing this as they're passing around the sun. We see clouds formed and rising off of things like this. If you've ever watched one of those cooling towers at the nuclear plants, you know that this cloud just continues to trail on beyond that, and you can see it go off into the distance. This is basically what's happening now with these materials flying through space, that are this ice being heated up by the sun on one side, so things are rapidly evaporating and leaving behind this trail. Some of that is being given off, and the sun's radiation is now polarizing it, so it's breaking apart the molecules, making positive and negative charge, and you'll see some of them just push straight directly away from the sun, where other particles will be just kind of a stream still following in the arc of this elliptical orbit. So a lot of times you look at a comet and some of these neat pictures that there are, and you actually see like two tails.
Yeah.
And that's because the two types of materials being given off, some are by the radiation and electrical effects that are being caused from the magnetic fields and all, and the other is just a simple material being ejected by mass. So the mere fact that we have comets, though, points out to us that it's hard to imagine how we still have comets if our system is billions of years old. That if each time an object comes around the sun, we're evaporating off more of the ice, it's boiling away. If I leave a pan sit on the stove long enough, filled up with water, it doesn't take too long with all that cloud of steam coming up before the pan's empty.
Yeah.
And then I'd have a problem with my pan because I burned my pan out. But it's eventually gone, so we exhaust the resource we have. Same thing with comets. You would think now, after billions of years, that we would have surely exhausted all the potential comets that would be around. And comets should be a rather rare thing, not something we see quite a bit. And so it really does argue for a fairly young solar system. And with that, I think we find that there's a lot of interesting things associated. Some of this debris that comes off, by the way, has little chunks of iron and silicas and things inside this ice.
Yeah.
And they leave a debris trail behind this comet as it goes by. And then each year when the Earth comes around and passes through the tail of that comet, or that elliptical path that it's traveling on, we pass through some of that little dust stuff that's left behind. Some of them are very small, some of them a little larger. And we'll see them fall through the sky as meteors.
Yeah. Speaking of meteors, back in the 60s, I'm a teenager. I'm in Collinwood, where I live now, same street. It's about 9 o'clock at night. I'm walking home from the store. And I hear this sizzling sound. Wow. And the whole sky lights up as if it's broad daylight, folks, broad daylight. I look up, Ken, this massive meteorite, fireball, going northward down into Lake Erie, crashed, and it got black again. I've never been able to find out the date when this happened.
Wow.
But I wrote to astronomers in Cleveland. I figured it'd be a record of it, but no one seems to know when it happened. Most fantastic thing I ever saw. Where do meteorites come from? How do they originate?
Well, meteorites are, again, some of them just fragments of comets. Other ones are probably fragments of these asteroids that are out bumping around occasionally into each other in our solar system. That the asteroids look basically like a planet that never came together and formed, or else a planet that one time was hit by a very large object coming into the solar system and broke a planet completely apart into this whole belt of area that are lots of objects. And some of those pieces are falling on. Also, people propose that some of these are pieces of the moon, because we see the moon's been bombarded by some very large meteors because of the size of craters we see. They calculate that some of this material would be ejected, and it'd leave the Earth's or the moon's gravitational field and maybe fall into the sun's gravitational field or the Earth's gravitational field. And then eventually the Earth's gravitational field will suck them in, and we'll see them shoot by us as a meteor. So when these land, they become a meteorite now once they've actually landed. So the larger ones do occasionally land or break up and kind of fall to the ground. And there are people who go out there and look for these pieces, and they find that there are different chemical makeups. Some of them do look a lot like what we found when we tested moon samples.
Have you seen one before?
I've just seen pictures of them.
Oh, you've never seen a live meteorite?
I've probably seen some
Okay.
at the museum, but at the Natural History Museum, but it's been a while since I've been there, and I don't remember right the moment.
I think I've seen two in my life. One was really small, like a little firecracker I saw over Lake Erie, but then the other one I told you about. I would like to find the date of that one.
You mean a meteor or a meteorite? I've never seen a meteorite.
A meteorite, I mean.
Oh, I did see a meteor. It was very interesting one time. That we had just started a vacation down on Hilton Head Island. We had walked out to the beach. We were just getting to the beach. I looked up on the sky, and all of a sudden I see this streak coming across, moving rather slowly, like a very fast jetliner. But then it was like breaking up into small pieces, and it traveled an arc about this far, just gradually breaking up into smaller and smaller pieces that then just disappeared.
Yeah, it dissipates.
So evidently there was a meteor traveling kind of a glancing blow across our atmosphere, but as it got through the atmosphere, it got torn up enough by all the heat
Yeah.
like the returning space shuttle and things, that it tore it apart. So I've seen that happen. It's very interesting.
No, yeah, I mean, comets and meteorites are very interesting entities in space. Life in outer space. We've all seen the movies. Flash Gordon from the 1930s, the serials. Great movies like The Day the Earth Stood Still, 1951. 20 Million Miles to Earth in 1957. Three Stooges in Orbit. We couldn't wait to go see that one, Ken. 1962. Of course, everyone knows 2001 Space Odyssey, 1968. Alien in 79. Sigourney Weaver. Yeah. And, of course, the Doctor Who things on television. And Star Trek, I guess, life in space in those episodes. What do you think? Is there intelligent life in outer space right now?
Well, sometimes, to be a little humorous here, I wonder if there's even intelligent life on Earth. So we kind of stepped into that one. I'm not sure we need to be called intelligent life, but I guess we are.
Yeah.
Are there beings like that? I don't even worry about whether there are intelligent life forms. Are there any life forms? Are there even little amoebas? Are there even little viruses, things of that sort that can exist in other planets, other places in the universe besides here on Earth? And what some of these folks have done studying it over the years that are creationists have done calculations of how many collisions it would take to bring together the carbons and nitrogens and hydrogens to begin to form some of these very precise chemical structures that are required to make up life. And it turns out that the odds to build something like some of these little DNA molecules and RNA molecules are beyond astronomical. It turns out that the calculations show that there hasn't been enough time in the universe yet. There hasn't been enough collisions with all the atoms and molecules colliding so far to even have a probability beyond what we would call nominally zero that there could even be something formed accidentally like that. And so my answer is no. I don't think enough's been studied for me to realize on Earth life is not an accident. It is definitely a miracle. It goes in the miracle class. It's supernatural. It is an event that would not ever happen by chance. Being a chemist, I'm very familiar with the idea of a lot of these chemicals that we deal with. Some of these things we're talking about in things that make up life are rather delicate. You need a very specific environment. The way a cell works, for instance, in just the smallest amoeba or whatever, there's all sorts of chemicals in there acting like a giant factory that each of them have to be in place, functioning well, before this thing is a living object. And it's not going to happen by chance. Even just forming those molecules, what we're finding is that when you study the statistics of molecular collisions, it couldn't have happened. And then you have to say, well, what if I built this piece by accident? It'd be just as hard to build the next piece, and the next piece, and then all these pieces are required for this to exist. And on top of it, the environments in which a chemist could make these kinds of objects are not the same kind of conditions where it would be conducive to life. You would be in a high temperature, a high hydrogen amount of atmosphere, a vacuum, different sorts of conditions we use to even start to build chemicals like that. Now, those very environments are ones that are not even conducive to life.
Right. Yeah, the SETI program for years, they had these, radio telescopes, putting stuff out there, never got a signal. What I say, Ken, is if we did get a response, don't let them know we're here, because if they would be so advanced over us, they can just kill us easily by putting something in our atmosphere. So I'm telling you folks, stop calling these people out there.
Well, it's interesting that there may have been an event that happened. We know that in the Bible that God tells us that there's these other creatures He's created we call angels, which literally is a word in the original language, just means messenger. And so God is telling us and treating them as if they're just messengers on His behalf that have come and spoken His words that He gave them to speak. And we know one visited, for instance, Mary. We're approaching this time of year, spoke to her in person. This was not just a person. This was now another being beyond what we see as human life. And how does that being exist somewhere else? I don't know, but it had to be a created being. It has the same problem we do. It didn't happen by accident. And the Bible does tell us that there were some of those angels that they called them the sons of God, had daughters, or visited the daughters of men, and they had offspring that became the men of renown in the ancient times. And some of those were thought to be very large people, the Nephilim, the Bible calls
giants,
them, the giant people. And so, yes, we may have seen some of that alien visitor kind of thing, if you want to think of it that way. But they may have been some of these beings that God also created and are in this other realm that he exists in that we don't normally see and perceive, that left their proper position and now intermingled with it, and so have created some other parts of our DNA that we may all share as maybe partly contaminated with some of this angelic material.
Interesting, yeah. Time travel. I've always been fascinated by it. Movies like The Time Machine, Rod Taylor, 1960. Planets of the Apes, 1968, Charlton Heston. Back to the Future, 85, Michael J. Fox. Ken, I thought about if I can go, I'd like to go back in time. I mean, can you imagine being on the battlefield of Gettysburg? Watching Lee and this Pickett's charge stuff. I don't know why he did this. It's the big thing in Civil War lingo, why he would ever do this charge. He got slaughtered. Watching the Egyptians build things. But of course, being around when Jesus Christ was around. Do you think time travel is possible? I mean, do you think someone can go into the future and see what will be? Or can we go, like we're talking right now, outside of recording it now, is this gone forever? Or can we go back in time and see it again? What's your take on that?
Well, the take I have is that it basically is more of a philosophical than it is a scientific type question. We get into one of these areas where you can't even picture what would the science look like that would make that happen. But suppose we could perceive an object and develop it that created some sort of warp in space and time where we could actually have some sort of a wormhole effect that they talk about that would curve back to time at a previous date. And if we did that, and you and I were sitting here and we decided to step in this machine and go ahead another couple of years to see what was going to happen, or go back 1,000 years to see what happened. The problem is when we got there, we're sitting in empty space. The Earth is moving around the sun at a huge velocity. The sun is moving through space around the center of the Milky Way galaxy. The Milky Way galaxy has launched itself off and is moving through outer space, and we are never sitting in the space at the same space at the same ever again. We'll be vast distances from this in mere seconds. And we don't realize it because we're sitting captured in this gravitational field. We think we're in basically sort of a stable situation and we maybe can move ahead, come back. No, it's not true. If you literally jumped ahead another 10 seconds, the Earth would have shifted enough miles, we'd probably be sitting in a vacuum of space and be choking yourself to death and dying within seconds. So I think no, it's not probable that it would occur. If you did it philosophically, I think you have a problem once you understand the motion of things through the universe and the fact that you'd have to do something very dramatic to be able to even go back to the same space. So you're actually trying to land back on a moving target at a different time, so at a moving time. So it's something beyond trying to shoot a dime with a rifle. If you flipped a dime into space and tried to hit it, you wouldn't hit it. But at the same time, if you were changing how fast, what time that thing showed up, it gets even harder to do.
Final comment from you. Let me ask you this. Why should people, especially kids out there watching this, why should they get involved in astronomy?
Astronomy is a very interesting hobby to be involved with. I do it more as an interest and do a lot of reading and take the telescope and binoculars out occasionally. Some people like to do it as an observational thing. As I talked about early on, you just get this this sense of God's presence when you're out there. There's something about it that's overwhelming, that you can see that there is something beyond yourself. There is an immense amount of beauty. I love to look at these Hubble space photographs that they have from the Space Telescope. There are some beautiful objects out there, and what you see is, in my opinion, that God has a desire to see fireworks just like we do. He's created some incredible celestial fireworks that are magnificent beyond our ability to understand. They're gargantuan in scale beyond any ability we have to understand just how large these things are. And yet to God, they're just a little firecracker maybe going off. That's kind of how I see his perspective. And I also look at it and just see that it helps us understand God a little bit better. One of my closing ideas is that if I looked at Nehemiah chapter 9, verse 6 earlier today, and it said, "You alone are the Lord. You made the heavens, even the highest heavens, and all their starry hosts, the earth and all that is on it, the seas and all that is in them. You give life to everything, and the multitudes of heaven worship you." And I think it's up to us as Christians, as people wrestling with, oh, is this Jesus really a real person? Did he do what he claimed to do? Is this God really a being that I can begin to believe that really could exist? And the answer is yes, and he wants to have us involved with worship to him too. And he does have us very much in mind, and he had us in mind. And the psalmist, for instance, tells us that it's just amazing that he had us in mind when all this other material exists that he made.
And so if a person keeps an open mind and not a secular mind and become an astronomer like you, they'll say, wow, I mean, this had to have a designer.
That's right.
I mean, even our solar system is like a Swiss watch.
Right.
But yet the evolution is, it made itself.
Yep.
Thanks for coming down, Ken.
Thank you, Sonny.
We'll be doing it again shortly.
Okay.
Folks, he's right. The heavens declare the glory of God. You can't make a universe without a creator. It didn't come out of some silly Big Bang, because something cannot come out of nothing. Totally impossible based on physics. Hey, as always, say a prayer for the troops. Without you folks out there fighting in Iraq and Afghanistan, around the world, we're nothing. I'm not here, you're not there, we're probably dead or in some prisoner of war camp somewhere. And remember, if not for the American military being created long ago, our ancestors might have been killed, and none of us could be here at all. We never would have been born yet. So please say a prayer for them every day. I want to mention 4 soldiers to you now. Stanley R. Augustberger, World War I vet, killed at sea, February 1918. Private Duard Aldridge, World War II vet, killed in France, December 3rd, 1944. Private First Class Aaron Bruce Smith, Vietnam vet, killed 1968. And more recently, Ken, you know this, Corporal Derek A. Wyatt, Afghanistan, an Akron resident, killed December 6th this year. And the day after he died, on December 7th, Pearl Harbor Day, his wife gave him a child. So the young boy will never know his father, well, personally, but I'm sure they'll tell him how great he was. God bless the troops. Pro-lifers, Pastor Ernie Sanders, Pastor Dale Hinkle, Coach Dwayne Risco hosted the fire right here in the bat. Watch his show. Pastor Mark Valenti, Pastor Kenny Sundemeyer, God-fearing guys, and there's many more folks, men and women alike out there saving these unborn babies from being murdered by the wicked, evil abortion industry. God bless the pro-lifers. Rob, thanks a lot on the camera. Ken, thanks for coming down.
Thank you.
Most of all, thanks to you for watching. Until next time, may God bless each and every one of you. So long for now from The Creation Show.